Hello and welcome to week 3 of Python for Data Science. My name is Mildred. This week we are going to look at the Numpy library and then we are going to compare it with pandas, and we are going to look at how we load data and look at the kind of problems that the data can have and how we can solve these problems. In this lesson we are going to introduce the Numpy array and look at what broadcasting is. Now Numpy stands for numerical Python. For you to start using Numpy, you need to activate your virtual environment and then you pip install Numpy. If you already have Numpy installed, it will tell you requirements already satisfied. If not, it will go ahead and install the Numpy package. Then you can now import Numpy, and we use alias has, so we import Numpy as np. So every time we want to use any property or any function or method available in the Numpy library, we'll use np dot the name of that method. Now the Numpy library is used for working with arrays, and we know that we have the list data type in Python that we use as an array, but this is not as fast as when we use the Numpy array. The Numpy array is significantly faster than the list, and they are stored in a single contiguous memory block, which now makes it efficient to access and to manipulate by the different processes. Now if we want to check what Numpy version is installed, we can print np.version like this, and when I run this we have the version 2.3.5. Now let's look at how we can create array with Numpy. Let's say we have a variable a, and a is equal to, we use np.array, so we have the array method that we can pass either a list, a tuple, or any array kind of data type into this array method. So let's say we want to pass a list, and this list has numbers 1, 2, 3. So we've created a Numpy array. A is equal to 1, 2, 3. np.array, then in the pair of parentheses we pass in the list 1, 2, 3. Now this is a one-dimensional array. We can have a two-dimensional array. B is equal to np.array, and here we will pass in a list of lists. So let's say we have a list, and in this list we have two sets of lists. So we'll say we have 1, 2, 3, and then as a comma separated list we have another list, let's say 4, 5, 6. So this is a two-dimensional array, and so the shape of this is 2 by 3. When we say 2 by 3, let me write it here, it's going to be 2, 3. So we have 3 items here and we have 2 sets of lists, right? So what you have is 2 rows, 3 columns, or something like that. We're going to look deeply at it, but array doesn't organize data in rows and columns like pandas, and we'll see it as we go deeper. When we want to fill zeros, let's say we want to have zeros like this, we say zeros is equal to np dot zeros and then 3, 4. So you can pass either a list or a tuple here, all right? And let's say we want to do ones. Let's say ones is equal to np dot ones, and we want 5. Now we want to arrange. Let's say arrange is equal to np dot arrange. So I'm just trying to use the different methods that we can access. I'll explain them when we print them out now. Now when we have this, we're starting from 0, we are stopping at 10, and the step is 2, so we're incrementing by 2, all right? And let's say we want line space. Let me do line is equal to np dot line space like this, and take note of the spelling, it's not spelled as pronounced. Okay, so now we'll have 5 points between 0 and 1, so I want to just plot 5 points between 0 and 1. We'll see how this is useful when we begin to do plots. Now let's print from the beginning. Let's say we want to print the one-dimensional array. Let's see how it looks. So I'll come here and I'll say print. So I want to print a. Let's see what it looks like. Now we have a 1, 2, 3. So you see it's one dimension, just a list. When we want to print b, we have b 2 dimension. So we have first row 1, 2, 3, another list 4, 5, 6. So that's why we have 2 as the number of rows, 2, 3, which is going to be the shape of the array. And we'll see how we can use that shape method to get a shape of an array. Now let's print zeros. Now we are filling this with zeros, and we say we want 3 rows, so that's the shape. Now we put it as a tuple here, 3 rows, and we want 4 columns, but we want it filled with zeros. So 1, 2, 3, 4 columns, and we have 3 rows. So this shape is 3, 4, and we have a two-dimensional array here. If we want to see how ones look like, then we say we have ones and we want 5 ones. We have a 1z array with 5 columns here. So you have the row and then the number of columns, but when we use ones here, we just have only one value, and it just gives us the number of values or the number of columns that we have, so the number of items ones. So let's print arrange, and this will give you, it starts from 0, ends at 10, and increments by 2. So 0, 2, 4, 6, 8. Okay, so the end is not inclusive, it's exclusive, so it doesn't print the last or the end. And so let's print the lin, and this will give us 5 points between 0 and 1. So we're going to have some decimal 0, 0.25, 0.5, 0.5, 0.75. So this is very important when we begin to do data analysis and we want to plot some data points. Now let's look at the attributes of this array and how we can index. Now we want to see the shape. Let's say we want to see the shape of A. So you can print A dot shape like this. So the shape is an attribute in Numpy that is going to show you the shape of this, and the shape here is just 3, which is 3 columns. So when you see only 3 like this, it has 3 columns. The number of row here is not specified, so it's a one-dimensional array. When we want to do the shape of B, it will tell you the shape is 2, 3, which will give you the number of rows and then the number of columns. Then we want to look at zeros.shape. Let's put zeros, and then it will tell you 3, 4, because we want it to have 3 different rows and 4 different columns like that. And so you can check the shape of an array. We want to look at the dimension of an array. We use ndim like this. Let's say B is 2-dimensional array, so we'll say b.ndim like this, and when I run this, it will tell me it's a 2-dimensional array. A is 1 dimension, so it should give me 1 dimension. We want to check the data type. We'll say, let's say the data type of B, for instance, we'll say b.ttype. So these are the different properties we can access in Numpy, and this is in 64. We want to transpose, say b.t. T is to transpose. We'll see the use of this when we start data analysis there. And so when we transpose this, instead of you switch the columns to be row, the row to be columns, right? Because what we had before is 1, 2, 3, 1 row, the next row is 4, 5, 6. So let's print B here so you can see what the transpose does. So we first have 1, 2, 3, 4, 5, 6, and then when we transpose, it just rotates it to be 1, 4. So this column will now become a row, this column will become a row. So you can transpose your data points for you to do different types of analysis. We can index nested lists, like this B can be indexed. Let's say we want to print B, and what we want to print is the first row, so say 0, and we want to print the first column from the first row, something like that. Let me play here and I'll run. So I'm going to print the first, I'm taking the first row of item, and I want to take the index position 1, so that's the second. So indexing starts at 0, alright? So I'm printing the item at index position 0, which is the first list that we have here, and then I want to take the item from that item at index position 0. I want to take the second item, the index position 1, which is 2 here. So we can slice, and when we slice, just like we do slicing in Python, it's the same thing. You specify a start, and then so slicing is like start and end. So let's say, for instance, I say I want to put a colon here, a comma, and 1. So what I want to do here is to print all rows and column 1. Okay, so what it will give me here is 2, 5. Let's try this run. So I have 2 and 5. So I'm getting all the rows, row 1 and row 2, but I want the column at index position 1. So column 0, column 1 is 2, column 1 is 5 here. So 2, 5. So you see how we slice there. So if you don't specify a start, you just put a colon like this, it means all. If you specify a start, it will start from there, or it means start from the beginning. If you don't specify an end, it will stop at the very end of the array like that. You can do negative -1, which is the last item. So we want to practice more, refer to your lesson resource and understand how you do slicing. It's the same as slicing in Python. So Numpy has the ND-array object, and when we use the array objects to create an array, we create the ND-array, and then we pass either a list or a tuple or an array-like object to it. And we have seen how we can check the dimension when we use ND. Now you can also define the number of dimensions when you create the array using the ND-min argument when you create it. Let's say, for instance, I say array is equal to np.array, and then in a pair of parentheses I want to pass this list 1, 2, 3, 4, 5, and here I want to put an optional argument. I'll put ND-min like this equal to 5. So I'm specifying the number of dimensions this array will have. And when I print array dot, let's look at the data type first. Array dot data type we have in 64, and I want to print the dimension. So we'll say array dot ndim and tell me the dimension is 5. Okay? When I print the array, I will see that I have 5-dimensional array, which means I have a list of lists like that. So where this is practical is where we start doing our data analysis, where we want to generate random numbers. We're going to go deeper in these topics in our live web conference, and we're also going to go advanced as we go deeper in this course. We can have vectorized operations where we operate element-wise. Now Numpy actually operates element-wise, and it's fast because Numpy is implemented in C. So let's say, for instance, I have this array. Let's remove this ND-min here, and I have this array. Let's do 1, 2, 3, and I want to do an operation here. So I'll say y will be equal to, let's say I want to say array times 2, right? So now instead of 1, 2, 3, I want this to be 2, 4, 6, something like that, and I want z to be equal to array plus np.array, and I want to add 10, 20, 30 like this. Now if I print y, I will get 246, and when I print z, I should get 11 22 33, something like that. So let's run this, and I have 246 11 22 33. And so this is how we do different operations with NumPy arrays. Now we have this key concept called broadcasting, and broadcasting enables NumPy to operate on arrays of different shapes by stretching. So the smaller array will be stretched along the dimensions of size 1. Now the rules are, you compare shapes from right to left, the dimension must be equal or one of them is 1. Missing dimensions are treated as 1. So let's look at how we can do broadcasting. Now let's say we have a variable a, and a is np.array, and this will be, let's say we have the list of lists. Let's have a 2-dimensional array, 1 2 3, and then we have another 1 4 5 6. Now we want to have, so this is of shape 2 3, right? So we want to have another variable v, and v is np.array. Let's say v is just of shape 3, so we'll say this is 10 20 30. Now we want to broadcast, let's say we want to do a plus v. So because this is of shape 2 3 like this, and this is of shape 3, we want to broadcast so that it will stretch, right? And the rules are that we compare shapes from right to left, and the dimension must be equal or one of them is 1. And we want to broadcast this to add each row. So for instance, we want to say, let's say a plus, so this will now be equal to a plus v. Now when we print this, let's print a.shape, we print v.shape, and we print a plus. Now when we add a plus v, broadcasting takes place here. So let's run this. So we see the shape here, 2 3 for a, 3 for v, and then when we add a plus v, we have 2 3. The dimension of this is stretched to be the same as this. Okay? So this one we do is like we are broadcasting row wise, but if we do column vector broadcasting, let's say we have a column. I'm going to remove this. Let's say we have, let's say col is equal to np.array, and here we have a, let's have a 2-dimensional array. This is 1 and this is 2. Let's do it like that. So the shape of this one will be, so shape here will be 2 1. Okay, so when we do the shape, we are looking at number of rows and then the number of columns. So we have 2 rows and 1 column, but I'm using rows and column, but NumPy does not actually have rows and column, just to be able to understand the shape. Okay, so we have 2 1, and we want to broadcast this. Let's say col plus, call this col plus v, so this will be equal to col plus v. Now when we print out this shape again, so we'll print col.shape, v.shape, col plus v.shape. So we can see name is not defined. You mean np, sorry, here it's np.array. So when we run this, built-in function or method object is not subscriptable. So we're having this error on line 8 here. So we have np.array. I didn't put a pair of parentheses, I just use a square bracket. Alright, so I'll clear here and I'll run, and then we still have that col plus v. I just keep making mistake, uppercase. And so when I run this, and then we have the shape for the col is 2 1, the shape for v is 3, and when we broadcast it becomes 2 3. Now you see how the column wise broadcasting or column vector broadcasting is different from that of the row that we did initially. So when we did for the row, it's like the shape of the one with the lower shape now becomes like the shape of the first one was compared to. So for column, what it does is that it takes the shape of the row and then the shape of the column, and then use that as the shape for the new item. Alright, we can have something we call scalar broadcast, where we add 5 to every element. We saw that a while ago, where we can say a plus 5, and then it will add 5 to every element in a, like that. So one of the pitfalls of broadcasting is that the shapes that are incompatible will raise a value error, and the operands cannot or could not be broadcast together. That's the kind of error you get. So you see value error, operands could not be broadcast together. Then broadcasting can be memory friendly in many cases, but sometimes you will end up with intermediate large arrays, and so you want to be mindful of big arrays when you do broadcasting. So this is where we end this lesson. In the next lesson, we will look at NumPy and pandas and see how we can clean data and prepare data for use in data analysis. Thank you, and see you in the next lesson.